Let us continue with the measures of dispersion or the measures of spread in today's session also. So we discussed what is measures of dispersion. It is also called as a spread. Measures of spread or measures of variability. This is what we have discussed in the last session. Measures of dispersion, or some call it as a measures of spread or measures of variability. So now the question is, why do we need to learn measures of dispersion? First of all, what is measures of spread? It helps us to understand how far off the values are from the mean. Okay, with the help of by measuring the dispersion, we will get to know how far the values are away from the mean. So this is what, let's say when you plot the data set, you are given some value, the mean value is 2.5 and you have something on 1, 2 and 3 and 4. Okay, for 1, 2, 3, 4 the mean value is 2.5. The mean is there in the middle. Okay, and if you create if you draw a curve like this, the spread, this is called your spread, how wide the spread is. Or if somebody is asking you what is the distribution of the data, right? So this is what the distribution. The data is distributed symmetrically. In this case, symmetrically it got distributed. So here the distribution is normal. The distribution is normal. Okay, I will explain you what is normal, what is asymmetrical. So it is also called a symmetric distribution. Okay, so this is the data set. When you given the data set, the mean is here, and with the measures of spread or dispersion or variability, we are able to understand how far each value is away from the mean. This is my mean. This is my mean. Mean, we use a notation called mu, and the one is, so 1 minus 2.5, 1.5. The distance between 1 and 2.5 is 1.5, and the distance between this is 0.5. The distance is 0.5 again, the distance is 1.5, right? So the values are, so one is 1.5 distance away from the mean. So the measures of spread or the measures of dispersion gives us an idea of how well the mean represents the data. So we can say that way. So how well the mean is represents the data. So can I say, let's the 1, 2, 3, 4. This is the the weight of the babies. Let's say in a labor ward in a hospital, right? In a labor ward, 4 kids born. Each kid weight is 1 kg, 2 kg, 3 kg. So 1 kg is not possible. So anyhow, let's assume that 1 kg, 2 kg, 3 kg, 4 kg. Each kid body weight, the newly born kid's weight. And if you take the average, you get 2.5. So we can see on the average weight of all the 4 kids weight is 2.5. Okay. If the spread of the value in the data set is too high, right, we cannot use mean to represent the entire data. So in this case, we can use the mean value to represent the whole thing. Or let's say you have 1.5 or 1.8, the 1.8 weight, and 2 and 3 and 4. So we can say on an average, all the 4 kids weight is 2.5. Okay, 2.5 or so. Okay, we can say. If the spread is too high, for example, if the spread is too high, 5, 6, or let's say 4.5 and 5 kgs, right? So we cannot say that the spread is too wide here. We cannot use this mean as a representative in this case. Even after, with this data, let's say you are getting hypothetically, let's say your mean is 2.8, your mean is somewhere here 2.8. So this mean cannot be a representative of the data, right? Because the spread is too wide here, or the spread of the values in the data set is large. Okay, so right, so in the case of lesser spread, so lesser spread means almost all the values are closer. Let's say let's say this is also 2 and 2.1, this is 2.5, and let's say this is 3 and 3.5, right? So we can say 3.5 or 3.6. right? So almost all the spread is very less. Or let's say this is 2.5, let's say 2.5 kg is the average weight, and the mean, right? So just above this, if you see the values are 2.6 and 2.8 and 2.1, or 2 kgs, forget about these values. Okay, let's see if you get all these values, because almost all the values are closer to the mean, right? So the distance is too closer, hence in this case the mean is representative of the mean represents the whole data. Okay, lesser the spread, the mean represents the whole data. If the spread is too wide, obviously the mean, you cannot use the mean to represent the whole data. That is another purpose we can use measures of dispersion. The second the aspect of measures of dispersion or spread is, with that we can understand how consistent the data is, how consistent or inconsistent the given data is. So like we have seen the measures like mean, median, mode as part of the measures of central tendency. Even in the case of measures of dispersion, we have range, we have a measure called range, and we have a measure called standard deviation, we have a measure called coefficient of variation. We will explore it quickly about the range now. Range we have already discussed it. Anyhow, we will it will be a recap for you. Okay, I'll just walk you through the mean quickly. So what is, if somebody is asking you what is measures of central tendency, what is the difference between measures of central tendency and measures of dispersion, how will you answer it? The central tendency, as per the measure of central tendency, we are very particular about the central location of the data. The mean, median, mode, right? So these are all the mean, median, right? It's all central location. We are very particular about central location of the data, but it is not helpful to tell us anything about the spread of the data. In addition to knowing the central location of the data, we are also interested in knowing the spread of the data. Okay, because with the spread of the data, right, we can say whether the given mean is it represents the whole data or not, and also how consistent the given data is. With that, we are able to understand. Okay, so first we will start with the range. We already discussed about range. How do we compute the value for range? The range is we compute the range by subtracting or taking the difference between maximum value and the minimum value, right? So the maximum value here is, in this data set, is 20. If you look at this data set, the maximum value is 20 here. The maximum value is 20 here. The minimum value is 5 here. Similarly, the minimum value is 5 here. The maximum value is 20 here. But if you take the mean, maybe the mean could be same. Don't go by this mean. This is wrong. Okay. So if you maybe the mean could be same, but the spread is different. Okay. The data set itself different. But there is some kind of overlap. Here 20 is there, 20 is there, but 5 is there, 20 is there. But here also the minimum value is 5, maximum value is 20. Hence, for these both data sets, the spread is 15. Range, right? The range is nothing but the spread. So this is what? Okay, you have, let's say, you have 5, 10, 12, 15, 16, right? So, and you have 20, something like that, right? So this is the spread of the data, right? So how do you find out the spread? If the maximum value is 20, this is the maximum value, and the minimum value is 5. So this gives us the range. So the spread is 15. And if I put one more 0 here, the maximum value is 200. For this second data set, the maximum value is 200, the minimum value is 5. So it is your now 195. So it tells us for the second data set, the spread is too wide, 195. It gives us a wrong picture. Why? Because almost all the values are somewhat closer, though 5 is a little far away from this, but when you compare 5 and 200, the distance is too high. But rest of the values, if you see, almost it is closer. Just because I have one outlier, right? So one outlier, if you use with the range measure, it misleads us to think wrongly that the spread is too wide. Actually, it is not too wide. Just because you have an outlier, it tells me to 195. So higher the range value, the larger the spread. Higher the range uh, tells us larger the spread, but actually it is not larger, right? So it is not wider. The spread is not wider. Whereas here, lesser the range value, so it tells us very clearly it is not so wide, right? Almost all the values are closer. Whereas here, so hence in the case of range, it is it is considering only the maximum and minimum value. It is sensitive to outlier. The range shows the width of the data, but not how it is dispersed between some bounds. That is also another drawback of range. Okay, so what? So in this case, we have some issues, and what we will do is, okay, now let us explore another measure called standard deviation. Let us see how standard deviation is, helpful compared to range. Standard deviation. So you have something called standard deviation. What is standard deviation? School time we studied. What is standard deviation? What are the applications of standard deviation when it comes to the business scenario? The standard deviation tells us the spread of the data, like a range, right? Even standard deviation also is helpful to understand the variability of the data in various domain, right? So you take it finance domain, or in the case of forecasting or polling or manufacturing unit, right? So the standard deviation, with the standard deviation, we are able to identify the variability. It helps us to understand the variability in the data. Okay, so the standard deviation is a measure of how close or far are the observations to the mean distribution is. Let's say here in this case, I have randomly sampled 10 customers. Each customer's amount spent we have noted down here. If you take the average of this, I get 250. This is my mean. Okay, so average, so in statistics, the equivalent synonym is mean. Okay, so henceforth, if I specify mean, you just understand it is an average. Okay, so the mean for all these 10 customers amount spent is 250. Now I call this amount spent as xi, because we have more than one values are there, right? So xi, and here I equal to 1 to n. I say I equal to 1. So x1 is 250, x2, x3, x4, x5, x6, x7. Okay, so this is my x bar. Let's assume that this is a sample. I said, right? I said initially we have randomly sampled 10 customers amount spent. So when it comes to sample, we use a notation x bar to represent mean. If it is a population mean, we use a notation called mu. This is a sample mean, hence we use a notation x bar. You need to subtract the mean from each and every value. So 250 minus 250, and 345 minus 250, and 280 minus 250, and 290 minus 250. So here, let us generalize this one, right? So what is this? Xi minus x bar. Subtract the mean from each and every value. So 250 minus 250 is 0. So which means this value is 0 units away from the mean. So the mean is 250. So the mean is there in the middle here, right? So this is my x bar. If you plot it in a chart, you will get something like this. The mean is there in the middle, and the data also 250. This value is same as your 250, or it falls on the mean itself. Okay, both this value and mean are coinciding here. And 345, the next value is 345. So 345 minus 250, so it is 95 units away from the mean. Let's say this is there here, 345 is here. Okay, next one is 375. Likewise, you need to subtract the mean from each and every value. So if you look at the second value, I repeat it once again, this value 345 is 95 unit away from my mean. So the formula for finding out the standard deviation is, like this one, x minus. So in this case, I've used the notation mu. Mu is your population standard deviation, or you can use x bar also, sample standard deviation. X minus the mean value, xi here, xi minus mean value. So you need to find out the difference between the actual value and the mean for each and every value, and then you need to divide that by your total number of samples. N is nothing but number of observations in the population. So in this case, how many number of observations? 10 values are there, 10 records are there. Sorry, 10 records we have taken, 10 observations. In statistics, instead of saying records, we use a term called observations. Number of observations, or number of, some people they say data points, number of data points, number of, this is a commonly used to number of observations in the population, N. So for each and every value, for I equal to 1 to n, so what we will do is we will subtract the mean from each and every value, okay, given value, and then you square it and then you divide that by n. So that is what your variance, this is called your variance. And if you take a square root of this variance, we call that as a standard deviation. If you take the look here, square root of the variance. Variance we specify a notation called sigma squared variance. So don't worry, right? So you know, how many number of notations do I need to remember? Nothing. Hardly maybe 10, maximum 10. That's all. So x bar is x bar represents sample mean, mu represents population mean, the sigma squared represents variance, and if you take the square root, the 2 will go away. Sigma, this is your standard deviation. This is your standard. If somebody says what is the sigma value, they are asking about standard deviation value. Fine. Now let us look at here. So the mean value for this one is 234.8 for all these values. If how do you compute the mean value? Sum of all these values divided by 10. So you get 234.8, and the next step is you need to subtract the 234.8 from each and every value. 304 minus 234 that's the formula here, right? Xi minus mu. For every value of the x, you need to subtract it with your by your mean value. Okay, so xi, this is my xi. So for each and every value I need to subtract. So 304 minus the mean value. So this is, in this case, the x value is 50. The value x value is smaller than my mean value, hence I'm getting negative 184.8. So everything is fine. So we have plus value and negative value is also there. You need to notice this very carefully here, right? So and the next step, what we are doing is we are squaring this value for each and every value xi. For each and every value, what I am doing is, so already I have subtracted the mean from each and every value, and somewhere I am getting positive value and somewhere I am getting negative value. Now what I am going to do is I am taking the square root of this one. I am taking the square root of these values. Why should I take the square? Not square root. I'm squaring the values of each and every value. I'm squaring it here. Why do I have to do this? Because here I have a negative value, right? So when I add all this value as it is, what will happen is the positive value and negative value will get subtracted. I don't want that to happen. Okay, if this gets subtracted, I will not be able to know the exact variance. So in order to I want to add all these values without subtracting it, irrespective of the fact that I have some negative values, right? Even if I have negative values, I need to add it. Okay, I don't want to subtract it. So only way out is you need to square this. Well, if you square it, what will happen? So minus 184.8 into minus 184.8. So minus into minus will become plus, right? And you get this value. So this is how we are going to overcome this issue. I don't want to subtract the plus and minus value. Okay, even if I have the negative values, so that value should get added instead of subtracting it. So the only way out is we need to square the value. The minus into minus will become plus, plus into plus. Here plus into plus, obviously it is a plus only. School time we studied, right? So this one, and finally we need to add all these values to get your variance. To get your variance, you need to add all these values, and then you need to divide this value by total number of samples or the number of observations. So what is n here? 10. And x minus mu whole squared, if you add all this value, you will get something. I did not note down here, I did not specify here. So let's say you are getting some value, right? And if you divide this by 10, you will get the variance sigma squared. And if you take the square root of the variance, you will get standard deviation. So in this case, the standard deviation is 22.3. Look here, the variance formula is, you have to remember this, variance and standard deviation. Sigma squared is equal to, for I equal to 1 to n, xi minus mu whole square divided by n, and standard deviation is the square root of this. And if you take the square root on both sides, what will happen? The 2 will go away, right? Sigma squared, the 2 will go away, it will remain as sigma. It's something like, if you take the square root of 2 squared, what will happen? 2, right? So 2 squared is 4, and if you take the square root, you will get 2, right? So that is what this. If you take the square root on both sides, the 2 will go away, sigma, only the sigma will remain here. On the right side of the equal sign, if you write, you need to take the square root. So that is what your standard deviation. Standard deviation is equivalent to sigma squared. We can say that way also. Sigma is equal to sigma squared. We can say, square root of sigma squared, right? So we can say that way also, or you can remember this way. Okay, now you understood what is standard deviation, right? So the standard deviation you understood. With the help of the standard deviation, we are able to understand how far each value is away from the mean. And then now the question is, why do you see, they might ask this, can you please tell me the formula, how do you compute the standard deviation? So I need to take the mean for the data set and subtract the mean from each and every value, and then I need to square the value. Now they will ask you why you need to square the value. To obtain variance, I need to add all the values of all the values of x minus mu, right? So in that case, what will happen is, if I don't square it, the positive and negative value get subtracted. In case I have any negative values, it will get subtracted when I add this. To overcome this, I need to square these values, each and every value. Okay, so now you understood. It is pretty simple to compute the standard deviation, to find out the standard deviation, right? The next question is, so when can I use standard deviation? Now, when it is really helpful when it comes to the business scenario. Okay, let's take a look at this example. So you have something called state of economy. If you look at the table closely, let's say you want to invest money on a stock market, but you want to be very smart, because you are a data scientist, you learn statistics, right? With this knowledge, you want to be very smart. Okay, you don't want to invest, you don't want to take a risk blindly, right? Let's say you have odd earned money, you earn a lot of money, okay, but it's all odd earned money. Let's say you are going to retire. Let's say in the next 6 months you are going to get retired, and you don't want to take any risk, because at the time of retirement you will get some lump sum money. With that money, you wanted to invest it in the right equities. Okay, you want to double up the money. You just think that way. Okay, so in that case, you don't want to you don't want to be too greedy by blindly investing on all these shares. Okay, you don't want to take any risk. Okay, so there are some equities. Equities are nothing but the stock share value. For example, HCL stock price is some value. Let's assume that 3,200. Okay, let's say today some value is there, and if you invest it and if you buy this one, each share is 3,200. After after a month, if the share price goes 3,000, 4,200, it is good, right? Somebody says, hey, you invest money on let's say 13,200, and after a month, each share price will go up to 14,200. But this is the best case scenario. In the worst case scenario, So let's say 8,200. Let's say COVID situation or something like that. Okay, some due to some sudden economical downturn happens, because of which the price have gone down, or because of the company is not doing good. The company chairman or CEO got changed. Okay, so in that case the price went down. The risk is very high here, right? So almost 50%, right? So you are going to lose 50%. You invested 13,200, and the next month you have some, let's say for your daughter you want to conduct some marriage, right? So the price goes up, it is fine. You are going, let's say 16,200. The return is high, but the risk is also very high in the case of HCL stock price. So now let us take a look at this one. Okay, if you look at this chart, look here, this is the probability of a state of economy. In the case of boom, normal, recession, if the economy is recession, like the COVID time and all, right, a lot of layoff happen. So in that kind of situation, the outcome of investment, this is my return. Normal, if the economy is normal, right, so everybody is going to work and there are no layoffs. So the normal economy is the 500. Boom is something like, now we are really doing good job. The Indian economy is very good, and especially in the software industry we are getting a lot of projects and we are so bullish, right? So in the case of boom, this is the expected return. This is the in the case of normal, and in the case of recession, this is the return we can expect here. So if you plot this data here, right, if you plot this, so this is let's say this is my Wipro data, Wipro share price, and this is my Infosys. If you plot this, you can see something like this. For Wipro, all the values are somewhat closer, right? So if you, let's say you buy the stock price at the cost of 400, it can go up to 500, or in the worst case it can you can get the return as 600. So per share you will get at least 200 rupees, or in the worst case you will get back your in the money, whatever you invest you will get back. Whereas in the case of Infosys, if you see here, the stock price is 200 here, but it can go up to 500, right? And suddenly it goes down to, let's say you invested there's a 0.25 probability, the price is this one 200, and suddenly, right, there is a 0.5 probability that it can go up to 500, right? So, or let's say instead of saying 800, I'm going to say something like this. Let's say this is the situation, there is a sudden fall. What will happen? So the prices can go down, right? Suddenly you are going to lose a big money here. Let's say the 200 and suddenly it falls down to 70. You just the Infosys stock price is not this less. Okay, hypothetically I took these values, and if the value is this one, the day of investment, you per share the cost is 200, and in the past, right, you are just so these are the past data, you are just looking at it. So but seeing this, there is a volatility here, a lot of volatility, inconsistency. Suddenly it goes up, suddenly it goes down. It is too bad. But you don't want to take any risk. You are a risk averse guy. You want to avoid the risk. You don't want to take the risk. Okay, high risk, high return. In the stock market, right, you can see this kind of thing. High risk, high return. There are some stock price, right? It can go high, but you are going to invest, per share itself 13,000, 14,000, and if you are lucky, it can go up to 20,000 or something like that. You will get more. The risk is very high because it is so volatile, right? HCL prices can, or the Infosys or some other, stock prices can go high suddenly, go down suddenly. But per equity itself, you are investing too much. High risk, high. So you are a risk averse. You want to take the low risk. Even the return is moderate, you are okay. Or low return is also for you okay. Instead of keeping the money idle, so I want to get some return. Okay. So in if you are a risk averse, is that one, right? Low risk, low return. So in that case, look here how well the standard deviation helps us to decide out of these two given equities, which equity should I invest given my risk tolerance. Mine is risk averse. I'm a risk averse. I don't take any risk, right? So in that case, you can go for Wipro stop. Okay. So standard deviation, with this we are able to understand standard deviation is also used as a measure of risk. We can measure the risk, right? So in this case, the risk is less, whereas the risk is more. So with this, what we are understanding is higher the standard deviation, higher the standard deviation. Let's say high and low standard deviation. Higher the standard deviation means the average data point is far away from the mean. Higher the standard deviation, which means the data is fairly spread out of the mean, right? So let's say this is the line. Okay, this is my mean. The data points, right? The data is fairly spread out from the mean, right? So it is too far, the spread is too wide here. Whereas in the case of low standard deviation value, it is all closer to the mean, something like this, right? It is all closer to all this value is closer to, let's say the mean is 500, 500 somewhat closer to 400 somewhat closer to this one, and whereas here the 200, but it suddenly goes 500, suddenly you are getting something less. Okay, so in that case it is the risk is very high, right? So because the values are not closer to the mean value. Okay, and if I say the zero standard deviation, high standard deviation, low standard, zero standard deviation, what does it say? So all the data point is same. Well, this is rare, but it is possible. Okay, this is a very, very rare situation. See, the interview they might ask you, so my standard deviation value is very high. What does it say? So higher volatility is there. So low standard deviation tells us the volatility is less, or it has a less inconsistency. Which one? Low standard deviation. Zero, my standard deviation is 0, which means all the data point is same. This is very rare. Okay. So now you understood what is the standard deviation. With the standard deviation, we are able to understand how far each value is away from the mean, and we can use standard deviation to measure the risk. In the case of stock market, we can use standard deviation, and also we have seen with higher standard deviation, if the standard deviation value is very high, the data is fairly spread out from the mean. If the standard deviation is less, the spread is less. If it is 0, all the data point is same. Okay, it is not much difference. Okay, next we will take a look at another application of standard deviation. Let's say you have a startup e-commerce company. Okay, and you started almost a year back. So a year back you were receiving per month, let's say on average 20 orders, 20 to 30 orders each month. On an average you receive 20 to 30 orders. So your staff capacity was 20 in your company, right? So you have 20 staffs were there, and with this head count you are able to manage by delivering the goods to, or the products or the orders raised by the customers, right? You can deliver it with the help of these 20 people to 20 different or 30 different customers. Okay, let's say 2021, early 2021 you started this business, and now let's say by 2021 November your business started kicking up. Okay, let's say you are getting on an average per month 1000 orders. With this manpower you have 20 staffs or manpower, right? With this manpower, do you think you can deliver 1000 orders to 1000 different customers, or 1000 orders in a month? That too within 3 days time. Each order should get delivered on or before 3 days. On or before 3 days. Either 3 days or less than 3 days. This is the SLA for each order. With 20 custom staffs or manpower, can you deliver 1000 orders in on or before 3 days? It is not possible practically. Hence what you are doing is you started having a tie-up with 2 logistic company. Okay, so this is Blue Dot, and you have another courier company called So what is that here? I forgot. It's a very good name. So desk to desk, desk to desk, two courier companies. What you are doing is you are decided to have a tie-up with these two courier companies or logistic company because they have more manpower than us. So what you are doing is you call these two company managers and you are holding a discussion with them. You are setting the expectations very clearly. Hey, and nowadays we are getting on an average per month 1,000 orders. With our existing manpower, we are unable to deliver the products on time. This is the SLA. So on or before 3 days, each order needs to be delivered. So what you are doing, you don't want to rely on only one courier company. So right, you want to give 500 orders to this guy and 500 orders to this guy. So you are telling them, so each month 500 orders, I can assure that I can give it to you. You guys need to ship it on time. Shipping is not only sufficient. You need to ship it on time, on or before 3 days. So what happens? Okay, you signed a contract with these two guys, these two companies, and now you started. You're taking, you're relaxing now because you're not overburdened. Or your manpowers are not overburdened. So now you have Blue Dot and Desk on your behalf. They are okay to deliver it on time. They agree to deliver it on time. So now what happens, right? Everything's are going smoothly, and off late you are getting a lot of complaints from the customers, right? So the customer says we are not. Let's say you are running a survey with your customers to know about the customers' sentiment. So in that case, while doing so, you are able to understand customers are not happy with the delayed shipments. Okay, delayed shipments. So in that case, what happens? You are getting confused and you are calling your staff and you are asking them to take a look at it quickly, whether the problem is with desk to desk logistic company or Blue Dot. Okay, so what you are telling him, hey, off late we are getting it. So you take in the last month, this month, in the current month only we are getting complaints. What you are doing is you randomly take 10 different customers, the delivery duration. Whatever the delivery done by Blue Dot, you take 10 different customers, randomly sample duration, and similarly for desk to desk, you randomly sample 10 different customers duration, the delivery duration. So when you look at this data, let's now the data is ready. Your data analyst, knows Power BI, and he plotted a chart or a table and you give it to you. So when you look at these two data sets, what you will tempted to decide? When you look at this, what is the SLA? On or before 3 days you are supposed to deliver it. SLA stands for service level agreement. So this is something like, so you are setting some timeline. Hey, on or before 3 days, each order should be delivered. There is no excuse. Fine, they agreed, before signing the contract, these two courier company. Now the things are going fine. That's what, as a CEO, he is thinking about it. But when he ran a survey with his customers, he is getting complaints. And now the data analyst presented this data. As a CEO, when he looks at this, he could see that, Blue Dot delivered for this customer in 3 days, in 2.5 days. Okay, on less than 3 days he delivered. Very good. Good. So, but for the rest of the customer, delivered it on 3rd day only. Okay, fine. Still, it is meeting the SLA. And if you take the average of this one, right, the mean is 3 here. For this data set, the mean is 3. Even for this data set, the mean is 3. Mean is same for these two data sets. But when I look at this data set, so I could see that 1.5 days, even though the SLA is less than or equal to 3, he just delivered well ahead of the schedule. Excellent. But he messed it up. He missed the SLA. Here he missed the SLA. Here he missed the SLA. Here he missed the SLA. But if you take the average, you just take the average in your calculator, you'll get mean 3. Just because you have many small values and only few bigger values, right? When you take the mean, it misleads us to think on an average, on an average 3 days they are delivered all our customers. But here, if you look at, even though they delivered it on the third day itself, majority of the time, they never missed the schedule. They did not take more than 3 days. More than 3 days, very dangerous, very risk. Customers will get disappointed. See, 4 days, 5 days, 5 days, 6 days. Just because you have more. So, delivering it well ahead of the schedule is great, but missing the SL is not the is not acceptable, right? So he missed. But here, even though they did not deliver it well ahead of the schedule like this guy, but they did not miss the SLA. So there are some companies, you might have heard about this, right? SLA, if you miss this SLA, if you violate the SLA, that means if you deliver it, after 3 days, right? What will happen is it leads to some kind of penalty. The company has to pay some penalty. Okay, so those kind of things are there. So you already agreed and you have some kind of tie-up, and as part of the agreement also mentioned, if you miss the SLA, you are supposed to pay a penalty. So by putting penalty, you are making this guy, right, to deliver it on time. Hey, don't miss out. Even if you don't deliver it well ahead of the schedule, it is fine. Make sure that you are not missing the SLA. See, this is it's not possible, right? We cannot tolerate this one. But when you look at the mean, let's say you are only the measures of central tendency. The mean, you use the mean. Okay, so the average delivery duration by both the blue dot and desk to desk is 3 days. If you literally go by the mean value, you get convinced, oh, these two guys are doing good job. Maybe my competitors are, they are jealous of me, because of which they are giving some complaints. But what happens, let's assume that in this case we have randomly sampled only 10 customers. Let's say your manager is asking you to randomly sample 1,000 customers. Okay, so what will in the Excel sheet, you will have multiple sheets, right? You need to scroll down because 1,000 customers data, like 1, 2, 3, 10 up to 1,000 will be there. You cannot see everything in a single page, right? You need to scroll down. So first page, when you see it, so everything is 1.5 to 1.25, so 1, 2 is there. Obviously you're tempted to think there is no issue, this is doing a phenomenal job. But when you scroll down, and then only you will get to know that. If you have 1,000 records, fine. If you have let's say your customer base is 25 million. In the case of Citibank, their customer base is 25 million. Okay, so in that case, what will happen? You cannot keep scroll down. It will take a lot of time, but you are tempted to make a decision by the mean value itself. In that kind of situation, the data value is very high, right? If when you're tempted to think this one, it will mislead you. Okay, let's say you are. Let's assume that your data analyst, he doesn't know statistic, doesn't know standard deviation. He knows only the mean, and he comes back and say, on an average, both blue dot as well as desk to desk, they delivered the items on time. They did not miss out the SLE. Still, he is scratching his head. Who? The CEO of the company. Okay. Still, he wants to. Still, he is getting compliance. But when he explored the customers in detail, they are not competitors. Actually, they are your potential customers. They are the one in the past they used to purchase like anything. So in that case, you cannot literally go by this. Well, you are calling a data scientist, and he is taking the standard deviation of all these. So what is standard deviation? The mean is 3. You need to subtract mean from each and every value, and then you need to square that value and divide it by n, and then you need to take the square root. That is what your sigma. Standard deviation is sigma. So for this data set, the standard deviation is 0.235. For this data set, the standard deviation sigma is 1.81. What did I say? Which one is lesser here? All of you please type it in the chat window so that I can make sure that I'm able to hold your concentration here. Okay, which one is bigger? 0.235 is bigger, 1.81 is bigger. Which one is bigger here? Yeah, Lawrence. Gilbert 1.81 is bigger, Aruna and Jiva is 1.83, right? So 1.81, not 1.83, 1.81 is bigger than this one. So what did I say? Higher the standard deviation means the average data point is far away from the mean. That means too much of inconsistency. Remember this, higher the standard deviation value, too much of inconsistency. Okay, so with this itself we are able to understand the inconsistency is very high, right? So we can see some kind of inconsistency, they are not delivering it consistently. So inconsistency, right? There is an inconsistency in this data. Higher the standard deviation tells us, the more the inconsistency. Whereas here, lesser standard deviation. The values compared to this one, this is lesser. Hence, it is consistent. Obviously, most of the time, right? Consistently, they delivered 3, 3, 3, 3, and 3 here also. Only 2 times. Yeah, here only one occasion that, right, they delivered, they missed the schedule, but still 3.5 is acceptable, okay, and it is okay. But majority of the time, they consistently delivered it on time. But here, sometimes they delivered it well ahead of the schedule, sometimes they miss the SLE. So with this, we are able to understand, using standard deviation, we can compare the data set. Right? So using standard, we can compare the data set. What we can compare here? So we can compare the consistency, how consistent the data is. Higher the standard deviation, more inconsistency. Yeah, desk to desk is, a blue dot is good, desk to desk is not good. Right? So that's what we conclude. So now you understood how we can apply standard deviation in the real business scenarios with these two examples. And we have something else called Chebyshev's theorem. Okay, what this Chebyshev's theorem says is, for a symmetrical or the bell-shaped frequency distribution, 68% of the data points will lie within plus or minus 1 standard deviation of the mean. About 90% of the data set will lie within plus or minus 2 standard deviation of the mean, and practically all 99.9% will lie within plus or minus 3 standard deviation of the mean. So how many of you are aware of the Chebyshev's theorem? How many of you are familiar with Chebyshev's theorem? This is Chebyshev's theorem. Okay, this is a theory, okay, and I don't want to bore you with this theory. I'll just directly jump into this one. So this is called your bell curve, right? This is called, because it looks like a bell, isn't it? In the temple, you would have seen the bell. The bell is something like this, called bell curve, normally distributed data. They call it a bell curve, or in general, we call this a normal distribution. Normal distribution. Why we call it as a normal distribution? If you see, the tail is very small here, right? Its tail is small here. So almost all the values are somewhat close. This is my mean. Mean is there in the middle. Almost all the values, or if you look at the left side from the mean. So this is my mean. The mean is there in the middle. Okay. On the left side of the mean, if you see it here, right? The exact mirror of this one is on the right side. The right side area is the exact mirror of your left side. I can say that way, right? So like this, okay. So this is called your normal distribution. So what Chebyshev's theorem says is, the 68%, almost 68% of the data lies between minus 1 sigma to plus 1 sigma. Listen very carefully. Very simple one. I will make it very simple. Don't worry. Okay. If you on the left side of the mu, you can see minus 1 sigma, minus 2 sigma, minus 3 sigma. On the right side of the mu, you can see 1 sigma, 2 sigma, 3 sigma. I don't know how many of you worked on the 6 sigma projects in your projects. Okay, so those of you, the quality guys, they know. Okay, in the software company, right? The quality guys, even in the manufacturing company, the quality guys, they know what is 6 sigma. Right, so they use Chebyshev's inequality and all, the theorem and all. So here, what is mu? What is mu? Mu is the mean, right? Population mean. What is sigma? standard deviation. Sigma is the standard deviation. See how in the past the scientists made our job simple with this theorem and all. Okay, so mu is the mean, population mean, sigma is the population standard deviation. Okay, for sample standard deviation we use a small notation, small s. Okay, for sample mean x bar. Okay, remember this. Okay, so I'm going to say, instead of saying normal distribution, I'm going to say standardized normal distribution. Standardized normal. In the case of standardized normal distribution, the mu is going to be 0 always and sigma is going to be 1 always. Okay, mu is equal to 0 and sigma equal to 1. Okay, these are default values for a standardized normal distribution. You might be wondering, so why they use the value 0 and 1? You see, you are working for Walmart. Okay, last week what is the average sales? If somebody is asking you, okay, so the volume is very high, the data volume is very high, the average sale is 243,000 and 111.35. This is the average sale of Walmart in the last week in the Cincinnati location. Okay, so difficult to remember this value, right? It has a big number, huge value. Instead, let us standardize it. No matter what value you have, the mu is 0 and sigma is equivalent to 1. On the right side of the mu, you have 1 sigma, 2 sigma, 3 sigma. Okay, and the left side of the mu is minus 1, negative value, minus 1, minus 2 sigma, minus 3 sigma. They defined it this way. This is called your standardized normal distribution. Okay, fine. So now, what this theorem says is 68% of this data set, right? The value of this data set, lies between minus 1 sigma to plus 1 sigma, and 95% of the data set lies between minus 2 sigma to plus 2 sigma. 99.80% of the entire data set, right? Almost entire data set lies between plus 3 sigma and minus 3 sigma. Very simple. You need to remember these three numbers, 68.5. Simply remember 68, 95, 99. That's all. When it comes to Chebyshev, somebody is asking you Chebyshev theorem, these three numbers should pop up in your mind, 68, 95, 99. Okay, so Chebyshev's theorem says 68% of the data set values or the observation lies between plus sigma to 1 sigma to minus 1 sigma. 95% of data set lies between plus 2 sigma and minus 2 sigma. Fine. So what is the business application? So when will I use this one in reality? Let's say okay, let's take this example. You are the project manager. You are working in a software company. Let's say you are working in a TCS company. There is a medical camp currently going on. Okay, in your medical camp is there in your company. Okay, TCS. So each and every manager is responsible to make their team to undergo the medical checkup. Let's say you are the project manager in your team, including you, 20 people are there. Okay, the 20 people are developers. Let's 18 developers are there. One project leader and project manager is there. So all put together, 20 people are there. Okay, in your project. So what you are doing is you are going for a medical checkup, right? So you are going to the medical camp. So there is a small room. You take each and every person, and then you go for a checkup. So they are checking your heart rate. Each and every person's all these 20 employees heart rate, they are checking it, and they noted down something. The person one heart rate is 70. Other guy's heart rate is 66 and 80, 90. Heart rate varies from person to person, right? So this is 90. If it is 10, you cannot survive. Okay, 100. Right, and somebody is 86, 94, right? Okay, so this all the 20 guys heart rates are ready. Okay, so you got it. Now what you are doing is you are using the Chebyshev's theorem. Okay, now let's say the mean, let's assume that the mean heart rate is 70. You take all the employees, right? The 20 employees, or each employee is of your project, you take each and every value of their heart rate, and then you take the average. After you taking the average, you get 70, and you take the standard deviation. How do you take the standard deviation? You subtract the mean from each and every. 70 minus 70 is 0, 86 minus 70, and you square the value, and you take the variance, and then you take the square root of the variance, you get the standard deviation. Let's assume that your standard deviation is 10. Variation. Your mu is 70, sigma is 10. Okay, don't think anything beyond this. Okay, this, let's say these two values are given readily. Okay, the mu is 70 here, and the standard deviation is 10 here. In the place of sigma, you need to put 10 here. So 1 into 10, 10. So 2 into 10, how much? 20, right? So 3 into 10, 30. On the left side, minus 10, minus 20, minus 30. Okay. So now let us see. It's so interesting. Okay, how this one helps us to generalize. Okay. So with this, with the given mu and standard deviation itself, you can tell a story something like that. The 68% of my team members, 68% of my team members heart rate ranges between, this is 70, right? 70 plus 10, how much? See, here it is 70, here 1 sigma, right? So 7, so here it is something mu plus 1 sigma. Yeah, you need to mu plus 2 sigma, mu plus 3 sigma. Here mu minus 1 sigma, mu minus 2 sigma, here mu minus 3 sigma, right? So here, what is the value here? Mu is 70, mu plus 1 sigma, right? So 70 plus 10, 80, and this is 70 plus 20 is 90, and 70 plus 30 is how much? 100, right? So with plus or minus 1 standard deviation, 68% of my team members heart rate ranges between 60 to 80, right? 60 to 80. See, here it is 80, right? Mu plus 1 sigma, mu is 70, 1 sigma is 10, 70 plus 10 is 80, mu minus 1 sigma, mu minus 1 sigma. What is my mu? Mu is 70 minus 10, 70 minus 10 is 60. So 68% of my team members heart rate ranges between 60 to 80. So this area covers the 68% of the staff's heart rate values. Similarly, the plus or minus 2 sigma value covers 95%. 95. So with this, what message you can take it? What is the takeaway here? The takeaway message is the 95% of my team members heart rate ranges between 50 to here 90, 50 to 90, right? 50 to 90. So can you all type it in the chat window? 99.8 or 99% of employees heart rate ranging between which value? Can you all please type it in chat window? Let me see how many of you are able to understand, how many of you are concentrating here. Aruna 95.4. Yeah, so Aruna says 99.8. Yeah, 95% of the area covers, right? Which means 95% of the employees heart rate ranges between 50 to 90. 99% of the employees. Very good, Aruna. Aruna was able to understand very clearly. How about the others? Jiva is 90. What is 90? Okay, the 99%, right? No, it is not 90, right? What do you mean by 90? So I asked this question. 99% of my employees, look here, the 20, right? Of the 20, 99% of the employees heart rate ranges between which two values? Which two values? Okay, 42, 130, 42, 130, 90. Excellent, right? Bhavishya. Who is Bhavishya? Bhavishya is 42. Vidya, is Vidya, right? 42, 130. 99% of the employees heart rate ranges between 40 to 130. So the others, how about others? Sumati and Ashish and others. You're not able to understand, something wrong. Okay, please concentrate here, but don't be over conscious. Okay, just listen what I say. Okay, let me do one thing. I'll just close it and I'll explain it one more. So you need to be good with numbers. So no matter which job you go, right? When if you want to get into software industry, you should be good with numbers. See, the mu value is 70, the sigma is 10, the total number of staffs are 20, right? So with this value, you are given only these two. These are heart rate. The average heart rate is 70 of these 20 employees, and the standard deviation is 10, because heart rate varies from person to person, right? Okay, if you need to plug in the value here. So how you need to, here it is mu, but here mu plus 1 sigma, right? Here mu plus 2 sigma, here mu plus 3 sigma, and here mu minus 1 sigma, mu minus 2 sigma, mu minus 3 sigma. Simply plug in the value. What is mu here? 70, right? 70 minus 30. Sigma is 10. 3 into 10 is 30. So here 70 minus 2 sigma is 20, which means 50. So 70 minus 1 sigma is 1 into 10, 10, right? So you have 80 here. Sorry, it is 60. 60, 50, 70 minus 30 is 40. Bhavishya, she mentioned correctly here. 40, 50, 60, and here you have 70 plus 1 sigma, 1 into 10 is 10, 80, 90, here you have 100. So with 99% of the employees, heart rate ranges between 40 to 100. 95% of the employees, heart rate ranges between 50 to 90. And 68% of the employees, heart rate ranges between 60 to how much here? 80, right? Are you able to understand? Very simple concept. Still, if you are not able to understand, very good, Lawrence, right? So Gilbert also mentioned the correct value, and others, please and Aruna, right? Aruna also able to understand. Others, please watch my video one more time to understand. It's a very simple one. I made it very simple. Okay, now the another. So this is heart rate. Similarly, in the case of manufacturing unit, they use Chebyshev's theorem. Okay. So for example, you are a quality inspector. You are part of the testing team. So even the case of software industry, right? So the testing team also, they use this Chebyshev's equality. Okay. Okay, let's say let's say you are part of the manufacturing unit, and you are part of quality team, okay, and you are a quality controller, QC. Okay, you are the quality controller at the assembly unit. Let's say the machines are producing the products. Let's say each machine produces 10 pens, right? 10 pens. Each machine in your company, right? Let's say you are responsible for checking the quality of each pen, okay? Or screws, these are 10 screws, you just think that way, okay? Screws, okay? So they have given you the specification, the diameter of each screw. Diameter of each screw is, let's 3, something like that, okay? 0.03 and 0.03, and the height of the screw is, let's 1 inch or 2 inch, 2 point something like that, okay? They given you. So each machine produces 10 screws. You are responsible for this machine A, screws whatever produced. You are using something called vernier caliper, using which you are going to measure whether the screws produced with the correct sizes, the required sizes. The standard, let's say you are given the mean. So the mean value and standard, let's say for the sake of understanding, the mean is 5 and the standard deviation is 1 or something like that, okay? So in that case, your mean is 5 here, and so what you can do is, with this, what kind of story you can tell? You are not only one machine, you are conducting the quality control check or inspection for 2 or 3 machines, right? And then what you are doing, what story, and then you are coming up across this value. The mu is the average height of the screw is something like 5 feet, something like that, okay? and the variation, because machine to machine there will be some kind of variation, mild variation will be there, right? Or the same machine, one screw to another screw, there will be some kind of variation due to various reasons. Ideally, the variation should be very very less. If it is too high, you are gone. So what, in the manufacturing, right? So you have 5 here, and the 1 into 1 mu plus 1 sigma, and since people are not able to understand, I'm repeating this, okay? Mu plus 3 sigma, and mu, see, you need to improve your IQ, okay? You need to improve the speed also, understanding speed, because it's a very simple topic. When you, no matter what job you go to, IT industry, they expect you to be very very good, okay? So fine. When it comes to the absorbing things, okay? So here it is 5 plus 1 into 1 is 1. 5 plus 2 into 1 is 1. What is 1? 1 is sigma. 2 into 1, 7. And here 5 plus 3 into 1 is 3, 8. Right? 8. This is 7 and 6. And what is the me minus 1 sigma? 5 minus 1 is 4. And 5 minus 2 is 3, 2. So I plugged in all the values here. So why don't you tell me the story here? All of you please type it in the chat window. What does it say? 68% of the total screws manufactured. Let's say the total number of screws is, let's say, 1000. Right? 68% of the 1000 screws, right? Having the variation of between 4 to 6, right? Let's say this is the height. The height of each screw is 68% of the 1000 screws manufactured ranges between, the height ranges between 4 to 6 inches, 4 to 6 inches. Okay, so the specification is, let's say you are a manufacturer. Let's say you are Mr. Raj. Okay, you are the owner of a manufacturing company. You are manufacturing cars. Okay, and all these parts, most of the parts, you are getting it from different vendors. Okay, and so you are a car manufacturer, but you don't manufacture screws. What you are doing is you are outsourcing this to a subcontractor. Let's say you are a Jivanandam, right? You are Jiva. So you are having a factory, you manufacture screws. What Raj says is, hey Jiva, I can give you an order of, you need to produce 100,000 screws. I need to deliver it on or before 3 days. But there is a condition. You are so happy. Jiva is very happy. I got a good order. I'll have to manufacture 100,000 screws. I have manpower. I have the machine. Everything is there. Everything is good. Okay. But if we put a condition, on or before 3 days you need to deliver it. But what we will do is, we will send our quality control person to your manufacturing unit, and then we are going to measure randomly. We are going to measure the screws. If you find 100 screws, right? If you find 100 screws are not matching with our specification, then we are going to reject the entire lot, 100,000 screws. So for that, you need to buy raw material, everything, and 3 days you are making your employees to work in 3 shifts, and they are working day and night. You need to give them salary. You need to pay the money to your raw material. You need to buy it for them. The vendor, you need to make the money. You did everything, but end of the day, when he sends his person to your factory outlet or in the assembly line, when he sends his people to your factory assembly line, and randomly when they pick up 100 screws, and if they and they are going to inspect it using vernier caliper. So if the height is, let's between 3 to anywhere between 3 inches to 6 inches is fine. Okay, let's assume that way. Okay, so this is the specification. And if you look at this here, so here you have 2, right? 99% of the screws manufactured ranges between, the height ranges between 2 to 8, right? It is outside the limit. Then obviously is going to reject it, right? So it doesn't have time to measure 100,000 screws. do you think so to measure each and everything, so that within 3 days itself he has to deliver it? If you send even 10 staffs to measure each and everything, do you think practically you cannot do it? So what they do is randomly they pick up 100 screws, and even for that it takes 3 days or 2 days time or 2 days time, right? So with this we can tell the story. So for example, if it is between 2 to 8, right? So 2 to 8, okay, then it is fine, 98. The same thing can apply to the food delivery company also, right? So the hours, and within 2 to 8 hours if I deliver it, then it is good. Not only manufacturing unit, Swiggy and other things, right? Delivery time. So if they are 99% of the time, they deliver it between 2 to 8 hours or 2 to 6 hours. The mean delivery time is 4, and sigma is 1. So in that case, mu minus 3 sigma is how much? 4 minus 1 is, 3, right? 4 minus 3 is 1. 99% of the time we deliver it well ahead of the schedule. Between 1 to, here what will happen? So if it is a 4 and 1, so 4 plus 3 is here 4, and sigma is 3, right? 4 plus 3 is 7 hours. 1 to 7 hours. 7 is way too high. But if you look at the 95% of the time, so here mu is 4, and let's reduce the mean 3. So in that case, it is good, right? So even in this case, right, so mu is 3 plus 3, 6 hours. Even that is too high. Okay, 95% of the time if you apply it, what story you can tell? So mu plus 2 sigma, 3 plus 2, 5 hours, and here 3 minus 2 is 1, right? So 95% of the time we deliver it between 1 hour to 5 hours. This is okay. Okay, so you can say 95%. So by looking at this, they should be able to take a decision, right? The entire population. You don't have to take the entire data, and you don't have to measure each and everything, each and every delivery. You don't have to look at it. So by taking the mean value, if you have the mean value, computing the mean is pretty faster. In Python or including Power BI, you can get to know in a matter of second you will get these two values, okay, with the irrespective of the volume of the data, right? So you will get this in a matter of few minutes or few seconds, okay. So with this, you should, when you use this one, you will be able to get to know. You can generalize the population thing, right? You can infer the population thing, entire thing. So 95% of 100,000 screws they produce with this range of height. So is this matching with my requirement? Yes, fine. Similarly, medical, right? The blood sample, sugar, you take the sugar for 100 patients, and you want to take only randomly 10, you take the mean value and sigma value, and then you plot it here. So 95% of my patients sugar, fasting sugar ranges between 90 to 100. It is good. That means majority of the population are healthy. I don't know, 99.8% has 2 to 8 quality variation. Yes, lower end. 6 to 6.95, 3 to 7, 1 to 8 inches. Yes, correct. So how about the others? This is a very simple one, guys. Don't say, not able to understand. Then something, you need to work out on your side, okay? So you just, watch my video one more time so that you'll be able to understand. Alright, so now it is 1:50. Sorry, I took much of time, okay, then what I supposed to cover it, right? So 12:30 to 1:30, it is 1:50 almost, right? We will continue the session tomorrow. Tomorrow's session will take a look at what is percentiles and what is quartiles and what is box plot and how to find out the outliers. Those topics we'll cover it tomorrow. What I will do is I will upload the today's session video, and I'll share the link, and you save the playlist link, okay, and also subscribe to my channel so that whenever I upload the videos, you will get an automatic notification. You go and watch it, okay. So probably after 40 minutes you will be able to see my video, okay. Fine. Alright, so the study material, yes, Gilbert also. What I will do, as I told you in the last session, just now we recovered our website after a major problem. Okay, some guy, he deleted all the files.